Hi, welcome back to LeetCode. In this video, I'm going to discuss LeetCode problem 2641, cousins in binary tree 2. So first we will discuss the problem. Okay, then we will see some example how it's working. Then actually we will share the intuition and approach, how actually you can solve this problem. Then we will see the C++ code, and we will also calculate the time complexity, space complexity for our code. Okay. So what is the problem statement? Problem statement that given the root of a binary tree, replace the value of each node in the tree with the sum of all of its cousins values. So two nodes of a binary tree are cousins if they have the same depth with different parents. Okay. If they are same parents, then they are actually siblings. If they actually have the different parent, that means they are actually cousins. Return the root of the modified tree. So let's go to the example 1. So for this node 5, so we have to replace this value with the sum of all its cousins. So is there any cousins for this node? No, only one actually node is present, so that's why this will be replaced by 0 because cousins sum is 0. Similarly for this 4, is there any cousins? No, they are actually different node like 9 also, but they actually parent are same, both parent are same. For 4 parent is 5, and similarly for 9 parent is 5, so both actually have the same parent, so that's why they are actually not cousins. So similarly this will be replaced with 0. Similarly for 9 will be replaced with 0. Okay, now for this node 1, is there any cousin? And if there any cousin, then actually you have to calculate the sum of that cousins. So for this node 1, is there any cousin? Yes, 7 is actually one node present. That actually, for what is the parent of this node 1? 4. But what is the parent of this node 7? 9. Both are different, correct? So this will be a cousin 1 and 7, both are in the same depth also. What is the depth of this? Depth of this is 2. Similarly for what is the depth of this? Similarly 2. Correct? They mention that what is the condition for cousins? They have the same depth with different parents, correct? So 1 and 7 both are actually cousins. So what is the sum of cousins? 7, only one node is present, so this will be replaced by 7. Similarly for 10 and 7 actually are cousins, so this will be replaced by 7. Similarly for node 7, what is cousins node are present for, will be for node 7, 1 and 10 both. So what is the sum of that value? 1 plus 10. So that's why node value will be 11, correct? So let's take another example. 1, 2, 3, 4, 5, 6, 7. Okay. Now what will be the node value for this ultimately? Is there any cousins for this node 1? No. So this will be actually node value will be 0. Now for node 2, is there any cousins? No. So this will be again 0. Similarly for 3, is there any cousin? No. So this will be ultimately 0. Okay. Now go to the node 4. Is there any cousin? Yes. 6 and 7 both are actually cousin. So this will be actually ultimately 13. Similarly for 5 will be replaced by 13. And this will be replaced by, and for node 6, is there any cousin? Yes. 4 and 5 both are cousins for 6. So the sum is 9. So this 6 will be replaced by 9, and 7, similarly this will be replaced by 9, correct? So this will be your actually modified tree. So what actually observation? Observation is this: first of all, they actually mention that this actually have the binary tree. So binary tree means what? Any node will have maximum 2 child. Correct? Maximum 2 child. Now what will you see? Now what actually we need to do actually what? Intuition. What is the intuition? Okay. First of all, they mentioned this is binary tree. So binary tree means they actually have any node will have maximum 2 child node. Now for this node 1, how actually getting the node value is 0, modified node value, final node value. You can also check what is the first we have to find the which node actually, what all node are present in the same level. So what are the node present in this level 1? only node 1, correct? Now, is there any cousin? Is there any cousins for node 1? No. So this will, what will be the actually sum? Ultimate modified cousin sum 0. How actually getting? How actually we can get this 0? So what is the actual total sum? Total sum of on this level only 1. If I subtract that actually the same siblings, if I subtract that sum, I will get the cousins present on this same level. Like total sum is actually 1, and the siblings level is mean parents is same. So that time, what is sum of that? Sum of that is 1 again. So ultimately the remaining sum will is 0. That indicates what? The cousin sum of the cousins node. So this is actually 0. Okay, so this is ultimately 0. Now come to this level. Okay, so which node actually present for this level? 2 and 3, correct? So what is the total sum? Total sum is 2 plus 3, this is 5, correct? Now for this node 1, node 2, what is the sibling sum? Sibling sum is 2 plus 3, again 5, correct? You can check 2 and 3 both are actually sibling, so that's why that sibling sum is 5. Okay, now node 2 will be replaced by what? What is the total sum? 5, and sibling sum is 5 again, so this will be replaced by 0 again. Got it? Why it is finally 0? Similarly for 3, what is the total sum? Total sum is 5. What is the sibling sum? 5. So what is the remaining sum? 0. So this will be replaced by 0 again, correct? Now go to the next level, this level. Come to this level. So what is not present at this level? 4, 5, 6, 7, correct? So what is the total sum? 4 plus 5 plus 6 plus 7. So this is 4 plus 9, 9 plus 6, 15, 22, correct? Now for node 4, what is the sibling sum? What is the sibling sum for node 4? 4 plus 5. They are actually siblings, so total sum is 9. Okay, clear? Sibling sum is 9. So what will be the actually cousin sum for this node 4? So how actually get it? Total sum minus sibling sum. So this is 13. So that's why this node value will be replaced by 13. Got it? How actually getting total sum of on this level, whichever node actually present. Then check which actually node are sibling for this. Okay, sibling means parent is same. That sum actually we will get. If I subtract this total from total sum, the sibling sum, then I will get the cousin sum. This actually give the cousin sum, correct? It is clear? Similarly for node 5, what is the sibling sum? Again 4 and 5 both are the sibling for node 5. So then what is the cousin sum? Will be 22 minus 9, it will be actually 13 again. So this will be again replaced by 13. Okay, now node 6. For node 6, what is the sibling sum? 6 plus 7. You can check 6 and 7 both are actually sibling. Parents are same. Both parent is 3, correct? So that's why here actually the sibling sum is 13. So what is the cousin sum? How actually get? So total sum is 22 and sibling sum is 13. So this will be what? 9. So these both will be replaced by 9 ultimately. Got it? How actually it is clear? How actually intuition, how actually getting the output. Now how actually, so first of all do the level order traversal. Okay, level of traversal first will do. Then in level of traversal we have to find the sum of node values in the current level, correct? This will give the this sum is for level whatever node is present in the current same level, correct? Now I have to find out what is the sibling sum for any node, correct? Then ultimately node value will be replaced by cousin's value, means the total sum minus sibling sum. Correct? It is clear? Approach is clear? First of all, do the level of traversal. Why level of traversal? We will check what is the node actually present in the same level. Then we will find out what is the sum of that sum of the node value present in the same level. Correct? You whenever do the level of traversal, then actually we already add one condition and store the total sum. Then we'll check what is the sibling sum for any node present on the same node, same level. Then we'll check easily. We can actually calculate what is the cousin sum. From total sum, if we subtract the sibling sum, we'll get the cousin sum. Correct? So how actually we can do that? So suppose this actually 1, 2, 3, 4, 5, 6, 7. Now it is sure that root value will be always 0. Why root value will be always 0? And these two will be always 0. Because root can be present only one node. One node will be the root. So there will be no any other sibling or any cousin also. So that's why this value will be always replaced by 0. Similarly, for 2 and 3 also, you can check this will be always replaced by 0. Why? This is actually always clear. It is also always clear, but we will actually sharing this point. So 2, here actually maximum parent is only one parent is can be present. So what is the maximum number of node can be present? 2 only. Maximum 2. Correct. Maximum 2 node can be present in this level. Is there can be any cousins? No chance, because only one parent will be present in this level, in level 2. Correct? In level 1 only one node can be present. That's why in level 2 also only maximum 2 node can be present. So that's why again this value will be always replaced by 0. Now from next level, from level 3 to level n, any node, any level, then actually we can chance have non-zero possible. Correct? Cousin can be present. Now what we'll do, suppose we are in the level 1. Okay, then what we'll do, first of all we will iterate, we will check what is the child node of the node present in this current level 1. So what is the child node present? 2 and 3. So we have taken a variable initially 0. So I will iterate the child node. I will store this 0 plus 2 plus 3. It is 5. Okay. Correct. This is the sum of this level. Like we are in the current level, one above the level we are trying to do the operation. Like we are currently in the level 1, but we are trying to modify the level 2 actually, because I already know the level 1 will be always 0. Value will already replaced by 0. Root node will be 0. Now from level 1 to actually I actually trying to modify the level 2 ultimate final modified value. Okay. So I will check what is the child node for this. So this is 2 and 3. I have taken a variable. I will store the total sum. Now what will do? I will again store what is actually sibling sum. How actually we can actually calculate that? Again I will actually iterate this level 1. What I will do? I will check what is actually the maximum two child node can be present for any node. So for node 1, I will check. I already know the total sum. I have already calculated this after one iteration in this level of child of this. Now we are again iterating this level again. I will check what is the node child node present in this for this current parent node have. Okay. So for node 1, what is the child node present? 2 and 3. So what is sum of that? 2 plus 3. I will get 5. Okay. Then I will check. Okay, this is the sibling sum, and I will already know the total sum of this current level 2. So what I will do? I will just modify this value with total sum with the sibling sum. Similarly for this, total sum minus sibling sum. Okay, it is clear? It is clear, right? So this tree is currently look like 0, 0, 0. Okay, now actually we will go to the next level. Next level, you are currently here and you are trying to modify the level 3. So ultimately the tree is like 2, 3, 4, 5, 6, 7. Okay, now how to do? Currently I am here. So iterate all the parent node. This is ultimately the parent node. I am currently the parent node of the next level. Okay, so what is the sum of this? Sum of this, I will check what is the node of this child node. 4 plus 5 plus 6 plus 7. So ultimately the value is 22. Okay, so this one iteration to get the total sum of the next level. Okay, so I have got 22. Now again I have to iterate to check what is the child of the any node of the current parent node. This is suppose the current parent node 2. So what is actually the child node 4 and 5? So if I iterate this parent node, I will actually easily find out that okay, what is the left child value and what is the right child value. So I will check what is the sibling sum of the of 2. So what will do? What will get 4 plus 5? It is 9. Okay. Then actually I will modify this again. What is modifying? Modify with total sum minus sibling sum. So this will be 13. Similarly, this will be replaced by 13. It is clear? If you any doubt, you can comment on that. If it is clear for you, then also you can comment that it is clear. And if any suggestion, that also you can comment. If you like the explanation, please like the video. And if you not yet subscribed, please subscribe the channel. I have also uploaded some videos related to off-campus opening also. It will be helpful, I think. Okay, now go to the actually code. So first of all, we already know the root value will be always 0. Okay, now for level order traversal, we need actually one queue. Okay, and we are initially storing the root node into the queue. Now till our queue is not empty, we have to iterate, correct? And for level order traversal, we need to first find out how many nodes are present in the current level. So that's why I'm taking the size of the current queue size before doing the any processing, right? So this will give the initially 1 and sum is zeros. Sum is mean total sum. And vector of tree node, why? This is actually storing the parent node or the current level present. Okay, so till our while is greater than n greater than 0. That means I have actually till some node present in the current level. So I will actually I will actually iterate. I'll go inside the while loop and I'll find out the what is the node. So initially it is 1. So this is just tree 1, 2, 3. Okay. So initially in a queue we have only have 1. So this will be popped. Okay. So I'll check is there any left child. Yes, 2 is present. So our queue will have 2, and I will store the calculate the total sum also in the what is the child one. So current sum total sum is currently 2. Okay. Now is there a right child? Yes, 3. So I'll store this into the queue, and total sum is now 5. Okay, and I'm also storing the current node 1 into our vector, because again I have to calculate the sibling sum. That's why I'm storing 1 in this another different vector. Okay, now I process this. Now I will come to this for loop. For loop means what? To calculate the sibling sum. So this is the parent 1, node 1 is the parent currently. So I'll check what is the left child for this and what is the right child. So I'll check is there a left child. Okay, left child means what? I will actually subtract that value. This is sibling sum. So I'll subtract that value. Similarly, you can actually take another variable. Okay, the sibling sum as 0, and then actually you can actually add this left child and right child. Then actually you can actually modify this. You can also do that. Here actually what I have done, like I have already modified the total sum from total sum. I have taken another temporary variable t. Okay, that is initialized with total sum. Total sum is 5. So t is actually currently 5. Okay, then I will check is there any left child? Yes, left child is present. So 5 minus what is the left child value? Left child value is 2. So 5 minus 2, currently it is 3. Okay, then I will come to this, is there a right child? Yes. So currently sum will be 3 minus 3, 0. Okay, so this is actually we will get the after abstracts from the total sum to sibling sum. So ultimately we'll check, okay, this is the ultimate the value of sum of the cousins node. So if I have left child, I will value will modified with the this sum 0. Similarly for right child will be present, that will be modified the same value. Correct. Now again actually we will go to the actually while loop again. Our queue is empty now. 2 actually is present. So similarly I will our vector will be empty now. This vector will be empty and total sum will be now 0. Now we'll again iterate. I have actually 2 node. Okay, no problem. Is there a left child for 2? No. Is there a right child? No. So I'll store this vt in the our vector. Current node is 2. I'll store in the vector. Again I will go up to the, okay, this is a right child for node 3. No left child, no right child. So this will be again stored into the vector, and total sum is still 0 because there is no left child, right child. Again I will iterate this for loop to iterate this vector I have taken. So I'll check, is there a left child? No. Is there a right child? No. So there is no left child, right child. I will not modify this anything. So I return from this root. So what does the tree look like? Initially I modified this. This will be modified this root node as 0. This I modified with 0 again. I have modified this 0 again. It is clear flow. Code is line by line. It is clear. How is it getting? If the algorithm is clear, then you can actually easily code that, I think. So what is the time complexity of this? Time complexity. You can check. I am iterating level-wise traversal, right? Level-wise traversal of an entry. So each node only traverse only once. Okay. But for this for loop, we are actually iterating some parent nodes twice. So you can actually calculate. You can actually assume n plus k. Similarly we go in linear time velocity because we're actually for loop is iterating not nested, right? It is still parallel, this while loop and this for loop, not nested. That's why the suppose this actually we are iterating is not only once big of n, and here actually you are again traversing big of n again, so big of 2n. Okay, so but it is okay. Any other time velocity? No. So space velocity, what we have taken a queue. So maximum n node can be present in the queue. Correct. Any other things? Okay, we have taken a vector also here. So this can be also go up to big of n. So this space control will be a linear complexity big of n. Correct. This is for q, and this is for vector. Second time we are iterating, right, to calculate the sibling sum. Okay, I have already shared the code link in the description. You can actually check once again, and if you any doubt, actually comment on that. Okay, if you like the explanation, that also you can comment. It motivates me. And if you like the video, and also subscribe the channel.